Okay, so we're going to find percentage of data or area using the normal curve. And the first one we're going to do is from z equals 0 to z equals 1.28. And what we should do is draw what this looks like. And I want to use another color. So let's draw our normal curve. There we go. And here on this line we're going to have our z-scores. Okay. Right in the middle, in the center, we have z equals 0. I'll just draw this line like this. And to the left we have negative numbers, and to the right we have positive numbers. And here we want to know from z equals 0 to z equals 1.28. Let's say that's around here. Okay. I can't draw straight lines, that's okay. Let's shade in the area. Alright, hopefully that looks shaded to everybody. Okay, and we're looking for this percentage of data. So what we need next is to look at the standard normal table. And if you go to the course, there's under learning modules, it's the standard normal table, which is on your book, page 579. And what we do is we look up the z-scores. Now for z equals 0, we don't have to look it up. We're just going to look up z equals 1.28. Okay, and we'll explain why in a second. Okay, so let's find z equals 1.28. If I can move this. There we go. Here are negatives. Let's look for positives. 1.2. Okay, and then we have to get 1.28. And 8 is in this column, so we have 1.28 right here, which is 0.8997. Okay, and let me explain what that means, this 0.8997. 0.8997 is the percentage from all the way on the left to the z-score you look up. So we know that all the way from the left to z equals 1.28, we have 0.8997, or 89.97%. Okay. This is not the final answer because we don't have anything shaded in to the left of 0. We just want from 0 to 1.28. So I want you to think about how we would do this just for a second. Okay, so let's see if you figured it out. We know that to the left of 0 we have 50% of the data, and to the right we have 50% of the data. Which means that if we subtract 50%, okay, we're going to get our answer. Okay, so let's subtract. We don't need a calculator. And we get 39.97%. Okay, so that's right here. And you should take a minute to look at your answer and see if it makes sense in the problem. We know that this entire piece is 50%, and it's not filled the whole way. So 39.97 makes sense. Okay, I just want to explain again how we figured this out. So let's scroll down, and let's just look here. Okay. So the table that we have, the standard normal table, okay, right here, posted in learning modules, standard normal table, it tells us all the way from the left to a z-score we look up. Okay. So if we wanted to find, we have z was 1.28. When we looked up that z-score on the table, we figured out that this whole piece here, from all the way to the left to our z-score, was, what did we get? 89.97% for this entire piece. But we didn't want the entire piece. We wanted from z equals 0. Okay. So let's draw here. Here's our 1.28. Here's our 0. There we go. Our z-scores. We just wanted this piece here. Okay, so we have this whole region, and we need to subtract this piece here in order to get what's left. Okay, so that's exactly what we did, and we knew what x was because it's to the left of 0. Okay? Remember that when we have the normal distribution, we have 50% to the left of z equals 0 and 50% to the right of z equals 0. So again, we looked it up. For z equals 1.28, we got 89.97%. We subtract 50% to get what's left from z equals 0 to 1.28. And this is how we do any sort of problem where we have from z equals 0 to z equals something else to the right of that. Okay, let's try a different type of problem.